This will be lesson 9 of Machine Learning 101 lecture series, and today we are going to be talking about rules of probability as well as Bayes' theorem. So we are going to start with looking at rules of probability, and if we have time we are going to discuss Bayes' theorem. Now this lesson is very important because Bayes' theorem is one key theory in machine learning that is very important if you want to go far or understand many other concepts in machine learning. So I'd like to remind you to subscribe if you've not subscribed, and also you can like this video if it's been informative for you. So the previous lesson we discussed about basics of probability. Now I did not really go so far because I'll prefer you take your time to review probability, the basics of probability. So now let's start with discussing these 5 items. We'll discuss conditional probability, the sum rule, the product rule, Bayes' theory or Bayes' theorem, and then we do a brief summary. So let's start with conditional probability. So let's get to the system. All right. So there are 3 terms we need to know. One of them is joint probability, marginal probability, and conditional probability. So let's start with conditional probability. Let's also use the box of orange and apples from lecture 8, from the previous lecture. Now, assuming we randomly select a box, because there are 2 boxes, a blue box and a red box. Assuming we randomly select one of the boxes, and from this randomly selected box, we also randomly pick a fruit. So you notice that 2 actions have been performed. One, a random selection of a box, and secondly, the action of picking a fruit from the box. So now I'm going to write on the screen so that we can start using notation. So the first thing is, what is the probability of the box that is chosen? And second one, what is the probability of the fruit that is chosen? In the first case, we have 2 items. It can either be a red box or a blue box. And in the second action, it can either be an orange or an apple. So let's represent the first probability, the probability of choosing a box. Let's represent it using notations. All right. So now probability of choosing a box can be represented in this way. Probability of choosing a box can be represented in this way. So probability of choosing a fruit can be represented in this way, probability of choosing a fruit. And in this case, B represents the random variable that can take the value of either blue or red box. So let me indicate here, this is probability of choosing a box. Now, this does not mention what box it is. It's simply the probability of choosing one of the boxes. Now, this is the probability of choosing a fruit. Okay. Now, assuming that in the first action, you are told that the box that was chosen is the blue one. Or we are told the probability of choosing a blue box is, let's say, 6/10. Or let's say a fruit is chosen and the probability of choosing the fruit is, let's say, 1/3, as it were. So if you are given one of the probabilities, you can actually use this probability you are given to find the second probability. So let's put it this way. If we know the probability of choosing a box, right? Then what is the probability PF of choosing a fruit? So we can write it this way. Probability of choosing a fruit, okay, let's say choosing a fruit, given the probability of choosing a box. So this means conditional probability of choosing a fruit when we know the probability of choosing a box. Now, this now is terminology not a lot. So PB, this is conditional probability. So take note that conditional probability is represented in this way. It has a bar or a vertical line in between the two. Now what we have on the website is not exactly what it should be. So here we have conditional probability of choosing a box given the probability of choosing a fruit. Now when you have a probability like this, PB, this one is already known. So if you have a conditional probability P, probability of F given probability of B, then it means that this is already known and is called marginal probability. So marginal probability is simply probability of something happening unconditionally without effect with any other thing. So when we talk about what is the probability of something, we are talking about marginal probability of that thing. So it's not conditioned on anything. But conditional probability is conditioned on a previous probability that is known, right? Good. All right. So in this case, we have PB of F means the conditional probability of F given B. So this is actually a typo. So PB of F means conditional probability of B given F, right? So conditional probability of the first item or the first variable given the second variable. Let's now go to the sum rule. In this case, we will state the sum rule and then explain it, and later I will apply it to the apple and oranges. The sum rule states that the marginal probability is the sum of the joint probabilities of two different variables. Alright, so let's see what it means. Now we have come to another term, joint probability, and joint probability is represented in this way. So take note of the notation. So we have P of let me use fruit and box at this time again. So we have P of F and B is called joint probability. So take note that we have a comma in between the two. So you'd read it as joint probability of F and B. In the case in the website, we have joint probability of X and Y. P of X is known as marginal probability. So we have, this is conditional probability, this, and this is marginal probability, this is joint probability. So let's now understand what the sum rule is. The sum rule simply means that we can find probability of X by summing up all the joint probabilities of X over Y. But the question now is, how do we find joint probability? So using the case of the apple and oranges, if we may ask ourselves a question that what is the probability that the first item is the first choice, we choose a red box, and the second choice is also an apple. So joint probability is combination of two things. So you have this probability and this probability. What is the probability of these two things happening, not necessarily concurrently, but what is the probability that both of these items, both of these probabilities happens? Like I mentioned, what is the probability that a blue box is chosen on the first action and an apple was chosen on the second item? Both of them together, that is what is called joint probability. But in case of conditional, we are saying what is the probability that an apple is chosen when you are given the probability of the box chosen, right? Good. So in conditional, we know a probability beforehand, but in joint probability, we don't know this. It's not necessarily we know this probability beforehand. So this is the difference between the joint probability and conditional probability. I've also talked about the sum rule, that the sum rule is the marginal probability of an item, of an action, is the sum of all the joint probability. So let's illustrate again using the box example. So if we have, let me use the case of the box. So if we have probability of the B and we have probability of f. You already know that these are what they are called marginal probabilities. And now we are saying that probability of picking a fruit is equal to probability of picking that is summation of probability that of picking a box and a fruit at the same time. Okay, so basically something like this. But to clarify, let's say that the probability of choosing a fruit is equal to the probability in the first case and plus the probability in the second case. Let's just clarify a little more. So let's say probability that the box is blue and the fruit is orange. So the probability that the box is a blue box and the fruit is orange is what we can calculate using the sum of these probabilities. So we are going to calculate the probability that the box is blue, because we have two boxes, so it has to be 1/2, plus the probability that the fruit is an orange. So in this case, you consider that an orange was collected from the blue box, and consider the probability that that fruit collected is an orange. So when we take some examples, it becomes a little clearer. So one thing we are trying to say is the sum rule is written in this way. Now, what of the product rule? The product rule helps us to find the joint probability. Remember that in the sum rule we have joint probability expression. So we have joint probability of x and y. How do we find it? The product rule says that the joint probability is equal to the conditional probability of y given x times the marginal probability of x. Now read this several times. The joint probability of x and y equals the conditional probability of y given x times the marginal probability of x. This is what the product rule says. Now, what if we interchange x and y? So this you can try to do by yourself. We now have probability of x and y, that is a joint probability of x and y equals the conditional probability of x given y times the marginal probability of y. So it's simple. It's called, you can actually use the symmetry property. Yeah, that is the word I'm trying to remember. So you simply interchange the variables there and you get the same result, and that is the product rule. Here px and y is a conditional probability. Pxy, this is actually the joint probability of, so this is a mistake, so yx, the conditional probability of y given x, while pxy is the conditional probability of x given x and y. So we are having a mistake. So x and y, joint probability of x and y, pyx, conditional probability of y given x. Finally, px is a marginal probability of x, or just the probability of x. The question now is, how do we find conditional probability? Because now we know the formula for joint probability, we know the formula for marginal probability, which is in the first case. How then do we find joint probability? And this we can do using Bayes' theorem. And that is where the Bayes' theorem comes into play. I'm not going to do it at this point. I'm going to reserve it for the next class. And I'd like to see you in the next class. I'd like to thank you for viewing. Remember to subscribe and also share the video and like it if it's been informative for you. If you have any informative comment you would like to let me know, I'll leave a comment for me in the comment box below.